Okay, I think we are streaming. Let me just check that this is actually up. I haven't streamed for a while, for a few days. I've been actually a little bit sick, but thankfully getting past it. And I really wanted to dig back into the live stream. Oh gosh, I can see the thumbnail is not the one I really want. At least it's working. So it's gonna be a little bit of a weird angle today, because I couldn't really be bothered to set up the camera properly. Well, not that I couldn't be bothered, but it was a little bit easier right now. I'm working on the laptop, and I thought it would be good enough just to try this out, see if I can just hook up any time and start a stream. So let's see how this goes. I have been writing the game engine on the laptop a lot lately, so at least I know I can do that. This is the time where I wish I had viewers, so I'm not just sitting here all alone, but it's fine. Oops, that's the wrong folder. OddPixl. Right. I'm just going to change the... Oh, gosh. I don't have a good one. Oh, I really should have. This is okay. This is a good learning curve. So I need to make a, placeholder or something kind of thing. We're not doing specifically a game today, but I'll just reuse that thumbnail for now because it looks good and it's sort of in the right direction. We are eventually going to get to this, and I'll update that later. Okay, so excuse me, like I said, my throat is a little bit rough. So what are we going to do today? I thought first thing we could do is I can sort of go over some of the changes. The game engine has had a huge rewrite, and I know that's like a very, very common statement to hear from a developer. Oh yeah, I just wrote it again. But this is actually, I felt like this was really needed. So if you go back and watch any of the other streams, you'll know that I essentially was just trying to focus on writing a game. And at first it was a very specific game. That game is now online. You can go and check it out here. We created a nice site called oddpixl.com, and you can basically shoot your way through the invaders, and yeah, it's very, very simple, I would say, but it does exactly what I wanted it to do, which was, what is the quickest, fastest way that I could write a cross-platform game in Swift? So I would consider that to be pretty successful. I still have the game code, obviously, but I learned a lot while I was doing that about some of my approach and some of my decisions. And I guess the main thing I learned was when it got to the point where I wanted to lay out the invaders, or even just spawning the invaders. I had a very apps approach to it. Let's say, obviously I'm an app developer typically, so it probably makes sense. But basically, I had a very, very odd way of thinking about it, and I'd avoided doing something specifically like ECS because that felt big, and it also felt like a thing that would distract me. So I didn't want to do that. Still don't want to do that. But I have realized that you do need to have some kind of entity system so that you can spawn entities and despawn them and things like that. The other thing I realized was that my platform abstraction, maybe I should open this up. So the other thing I realized was the platform abstraction. So if we come down here to like, let's go with the Mac, but it's very, very similar for the WebAssembly build. So it started off nice and clean, you know, like the concept of a game port, right? And then I got to the render and I did manage to make this a lot smaller. And I thought I was actually really proud of this the first time because I wrote or tried to make this as short as possible, right? So the renderer code, including the shaders, is about 1,200 lines of code, right? And I thought this is great. And then I kept hitting these walls, you know, like, oh, I can't do that yet. All right, well, you know, the renderer can't do this yet. You know, like I can render a simple sprite, I can render shapes, and actually that was the SDF support was one of the best things I did, and I will be porting that over. It's not even really a port actually because it's largely shaders, so I will be bringing that over. And then, but so what was missing? I guess it was like I didn't have a way of doing like simple primitives, even like indexed cubes, for example. Like, I mean, not that I'm necessarily trying to move to 3D, but just my point there being that a renderer is really just dealing with, I mean, it deals with lots of things, but like one of the main things obviously is the concept of vertices and to render vertices with either a color or a texture, right? And I haven't really separated that concept and wrapped it in such a way that a platform would provide like the lowest level primitive types, and then I could introduce like something above that that gives me the conveniences. So what I was doing was kind of merging those two. Now I think that makes sense. If you're just trying to build a game, you don't need to get super complex. In fact, I went probably a little bit too far because I added blending and then I didn't end up using it in the game. It's a great feature, but I didn't end up using it. I've got a sandbox here. If I run this, I can show you. Oops, sorry, not on the phone, on my Mac. So let's run the game here. I had an update. Here we go. So basically I've got like my little, you know, sprite character and a little weird like sandbox level that I can just play around in. I'm pushing up here and I sort of hit edges, so the collision detection is working nicely. And I can also, like this here is actually set as a layer in the foreground. And this is not opacity, this is actually a blend mode, so I can see through as the player goes through it. All right, so it's a really cool feature. Up here in the top left, you can see that that shape is actually a capsule. So I have support for like complex rounded shapes, which is nice. And here we have like a little ramp, and you can see that I can actually walk up and down the ramp as well. And the little sound there, that's a detection for that collision, even though I can pass through it. So essentially, I added all the little basics and I thought, okay, I'm going to build a platformer at some point, right? But I have not really gotten there yet. And so I started thinking about the platformer, and I guess that's where I hit up the main issue. And that is that there are lots and lots more, like the step, it feels like the step from like a single screen Space Invaders to, let's say, the very first Super Mario is actually it's a pretty big step in terms of just thinking about a larger design. And there's sort of like fake physics that you have to think about as well. That's not necessarily in the renderer, of course, but I'm just, yeah, talking more generally. Also, another thing with the platform layers, I didn't add input in like the way you would think. I didn't have like keyboard events that I then just check in the game. I literally found that, you know, like if I was pressing the up key and then I passed that directly. Excuse me, but sorry about that. And that was a problem because, or it's still a problem, because as soon as I wanted to like share it with my kids on the iPad, they didn't really have touch controls. So they couldn't really play the game there. They had to use a controller. So I would like to improve the controller, keyboard, mouse, touch support so that it's a little bit easier from this day forward. Now, I'm not working on that right now because what I decided to do was to rebuild the renderer as I said, built on primitives. And I found this really great video from a guy named, hang on, why did that come up? I don't know where that sound's coming from. Should stop in a second. Okay, let me just kill the browser because I think it's coming from the browser. Sorry about that. Okay, there we go. So there's a guy on a developer, Horizon Engine, I think it's called. Yeah, this guy here, and he did a talk at Handmade Network, and this is an amazing, Gabriel. It's a really amazing achievement. I mean, I'm not going to be able to do what he's doing. That's absolutely fine with me. But he did have some really, really good ideas that I wanted to lean into. So I want to focus much more on 2D right now. All the games I want to make are pretty much 2D, although I do have one very big game idea, but we can talk about that another time. And for the game that I would like to make, or games, sorry, that I would like to make, 2D is enough. But I need to, basically, in order for me to like make the games and just focus on the game itself and the gameplay, I really need the lower levels to be right. So, okay, if you're not a Swift developer, this like package dependency setup might not make complete sense to you at first, so I'll do my best to explain it. In another video, if somebody watches this one day, then I'll do actual diagrams. But for now, essentially we have a breakdown. Sorry, just collapsing these. So these are my packages, and this one here is the actual game package. These are essentially libraries, okay? And together they sort of form the concept of an engine, so to speak. I would say it's more of a library than it is an engine. But anyway, so Pixel Platform is actually made up of also multiple smaller libraries. So the platform layer now provides basic types that any engine would want to work with. Any graphics or renderer would want to work with. So I heavily leaned obviously towards Metal because I am more familiar with it, but also I think it has a pretty good abstraction for the graphics layer. But I have done research and I've been, checking things with AI as well to make sure that things like vertex attributes, buffer layouts, things like that are relatively compatible with other graphics libraries, including DirectX and WebGPU, which is what I'm using now for WebAssembly. Vulkan is also, I have been looking into it, and that seems to be, again, like very familiar, but it is a much, much, much bigger implementation that I don't need right now, so that's not high on my priority. The two that I'm focusing on right now, honestly, is Metal and WebGPU. So basically you can sort of see from the file names here, I think you should be able to read this. I'm recording in 4K. Essentially you have, let's start from the bottom. It's not the right order really, but let's start from the bottom. You have the concept of shaders, right? So we have like a concept of a shader library and the ability to register functions. You have a runtime. This gives you, you can see here's a protocol. It's like an interface in other languages. So this defines the sort of the interaction between a platform and the game. There's game settings. This lets me pass in like, the title of the game, what FPS you want, resolution, things like that. And then we've got the concept of like something that you can draw, right? So a drawable is basically just a texture. But obviously that will, that could be a screen. It can also be a render target. So yeah, it's a primitive, okay? Here we have texture types of pixel formats. The texture with the resource ID. This is obviously what would get retained. We have a texture descriptor, so this is what you're going to pass into the engine. So, and then the engine will use the device, like your metal device or Vulkan device or whatever, to actually generate the texture, or the buffer, the data, basically, not the data, sorry, but the buffer. So yeah, these are like sort of descriptors, they're just friendly types for dealing with this stuff. And then I created the concept of like a resource pool. This generally doesn't hold huge numbers, although in a larger game later on it might. But I did make this pretty fast. So I have performance tests, and I can't honestly remember the number. Actually, I think it's not inside the Xcode project, but I have a performance breakdown of everything as I've been going. I think the performance pool, we're talking about, regardless of what the operation, I think all operations on average are like nanoseconds per operation, like very, very, very small. So the impact of this is very, very low. Then we've got the concept of like a buffer and buffer memory. But buffer memory is more like visibility, whether it's on GPU, CPU, things like that. Then we've got, what have we got up here? Similar to game settings, we have render settings. This lets you set up, it basically allows you to, this is the part where I'm not 100% sure if it's the right way to do it, but this is how I'm choosing to do it. So the game API allows you to then set up a render settings where you can pre-allocate. You essentially just specify the capacities that you intend on using, and then these get pre-allocated for you. It's probably not how most graphics libraries work out of the box. This felt like the easiest thing to me without overcomplicating every single game. Render pass. So the render pass. Okay, so the render pass stuff is like a little bit more complicated to explain, but essentially, if you've done any graphics programming, you know that you set up your buffers, you set your vertex, the bytes that you want for your vertices, and your descriptors, your pipeline, all of that stuff, and then you encode that, and then a render. So a render pass. I can't find my. Sorry, I have a specific type I'm looking for here. It might be at the bottom, actually. No, it's not there. Is it in here? No, that's... well, kind of. So render command here. These are the available commands, which are basically the real primitive things that you want to do. Like you want to set your render pipeline. You want to upload, or like define, sorry, your vertex buffer. You want to draw primitives, or index primitives, things like that. And then here we go. So, and then a frame, essentially you would do something like begin a render pass, and you'd pass along that descriptor, and you get back a render pass encoder, which then you can use to draw. So essentially, I've sort of, again, if you're familiar with Metal Kit, you're gonna sort of, I think this would feel fairly familiar. So this is the vertex types, and then we've got like the render target, and some of these are empty, like depth stencils, not used right now. Render target is basic texture, MIP level array layer, and then you've got your color attachment, so if you want to clear the screen, things like that. And then a color, just a basic color type that, with 4 floats. I actually should move this into a, actually I might add a note, move to SimD4. So, and then there's a, excuse me, and there's the render pipeline descriptor here as well. So hopefully you can see that the render sort of section of this library doesn't really do much. It just it wraps all of the Metal Kit, in this case, APIs. But because it's now custom code and it's written from scratch and it's in pure Swift, you use all of this code is exactly what you use to render for WebGPU as well. And later DirectX as well. And so you don't have to worry about switching to those other graphics APIs, which is really convenient and is going to make it a lot easier for me to do this in Swift. There obviously needs to be a concept of like a queue. and then some errors, and then there's the device protocol. So Metal device obviously conforms to this, and then WebGPU has an equivalent, and so this allows you to ask your GPU to like make a buffer or make a shader library, make a render pipeline, render pipeline, or a texture or a queue, and then of course you can have some destroy methods as well. Mostly this is kind of self-handled, and then that's also, compute is not introduced yet. So that is the Pixel platform, right? And then from there, you want to have specific implementations, right? So there's Pixel Metal and Pixel Wasm. I'll show you Wasm because it's relatively simple and we can go through sort of different library. So you set up like, some type that is your shader library, right? It's really, really simple in this case. For the platform, you can see here that it's very similar, but it's actually a lot shorter just because the web stuff is a little bit easier to actually port to, it turns out. So essentially you have, your texture descriptor, your drawable, and then your sort of present and all the queue and all that kind of stuff. And you just have to retain a few things, canvas being obviously the most important one, so you can render into that. If you go to the runtime here, the runtime is basically the thing that will run the app or the game. So in this case, it's going to run in the browser. If it was a Mac app, it would be the thing that launches the window, things like that. Essentially here, it like sets up the GPU or gets a hold of the GPU. This is all sort of necessary, but here we go. To request the device, so it's basically just a bunch of setup. Then we've got like the configuration. So, set the document title from the game settings. Set up the canvas itself so that it's going to be filling the browser window and things like that, and then also setting up the request animation frame so that we're like running at the preferred FPS ideally. This is always a little bit off. I had an issue, I don't remember what it was now. It was a couple of days ago, and AI added this. I think it's to do with clamping, but I need to look into that because I'm just, as I'm looking at that, I'm realizing I don't know what it is. I have a note for this separately. So, and then this is the thing that actually we call to run. I'll show that in a second from the game. And then there's the render pipeline as well. Again, like it just basically switches over the different topologies or primitives, and then it'll perform those drawings. So it's like so much simpler doing it this way, basically, is what I'm trying to say. The queue, I don't think I wrote this. I think I got AI to write it. I didn't know how to do this in WebAssembly at all. So I got a lot of help from that. The mappings I wrote by hand just because I'm an idiot. This would have been, after I did it, I realized this was just all boilerplate, but I think I just wanted to sort of have a bit of an idea as to like what maps and what doesn't. But anyway, Wasm device, yeah. So this is obviously like equivalent to like a Metal device. Yeah, and that just sets up like bindings and render, or like, sorry, the methods so that it can return a texture, it can return a buffer, things like that. So the port, obviously that's like focused right now just on rendering. There's no like input, there's no audio, things like that. But right now, just for doing rendering, it works. And while we're waiting, I will, scripts serve. Oh, I had this problem yesterday. I don't know what it is. No, it's still doing it. Something to do with what warp. I might switch to Ghosty, to be honest, because it's really annoying me. So if we let that run for a second, and then I can show you. Sorry, there we go. And so this is rendering 10,000 little tiny rotating triangles, basically. Nothing interesting, except it works, which is pretty cool. I don't know if you can even see, on my screen even, it's quite hard to see that they're actually rotating, but they are rotating. Some faster, some slower. Yeah, it's quite random. Okay, so basically you can see that actually works. And if I run this in on the Mac as well, just to prove that this runs on Mac OS and the web and it looks the same. There we go. And obviously with Mac we can like resize the window and things like that as well. And I've added some very basic like logging down here as well. This is actually like true measured metrics happening per frame. So here we can see like, let me just stop that. The game average, this is in milliseconds, is what is that, 0.009 milliseconds. So we're talking about microseconds here. And the render average is a little bit higher because obviously it's rendering 10,000 things. This is actually too high because we don't yet support instancing, and also I'm still single threaded at this point. So there's a lot of room for improving that. I did do a test. macOS can still run at 60 FPS with 100,000 triangles without issue, whereas WebAssembly actually just topples over and frame rate plummets. So these performance improvements are going to be necessary, not because I need 100,000, but I want to know what the capability of the engine is. So yeah, that's where we're at. So basically, that's all I'm going to go through in terms, realistically, in terms of this. The only thing I wanted to touch on was this pixel shader generator. Essentially, I wrote I did not really write this, Codex wrote this for me, but I got it to write a shader plugin. And what this does is it takes like the raw shader code in like text form in Swift code, and it generates platform specific shaders for me that then get correctly placed so that they're available to the app when it runs. And actually, if you saw when this runs, you can see here pixel loaded shader, pixel fragment, and pixel vertex. And if I search the project here for this, you can see that's this little shader here. And right now, this is simple shaders that just literally using transform for the camera essentially projects the point in space, in world space, and then literally just takes the color and blits it to the screen, or like uses that exact color for that pixel. Basically, there's no special clever thing going on with shaders. Because this is built into the engine. It's a very basic shader, but it works, right? And it's really cool because you can see here, I've not included any like game level shaders yet. So I need to see how this actually plays out later on. But for now, at least, this is really nice because my game is basically a very simple package. If you look at the package file, you just depend on Pixel. That's it. And then you can just write, you just basically conform, you create a game that conforms to Pixel game, or you can call this whatever you want, obviously. That's the entire code. I mean, there's a the name and the resolution of the game, but that's it. And so down here, this is a little bit of a hack. It's temporary, essentially because the render method is not mutable, and I want to rotate all these little things. I had to sort of create a class that I can mutate. That's changing though now, because now I can actually I think this might not even be used. Sorry, just as I'm saying that, I'm just realizing, because you can see here, I introduced a game context and the concept of a world, and now I can actually spawn a player, and those players are the 1000 that you're seeing, which means that this is probably not doing anything. No, it just logs metrics, which just logs metrics every 5 seconds. So, oops. Oh, I'm referencing something. Oh, okay. So I am still using state only for the for the 5 second basically thing. So what I can do is I can get rid of rotation. Again, this is very temporary because later on this will go in engine anyway. But okay, so basically you can see that it's not really doing anything. This is all the code here. So we set up a render settings. We need to allocate enough storage for all the things basically, so that we can launch 1000 things, right? And then you essentially call on here, you register your thing, right? In this case, a player, and then you can grab players and spawn, right? It's really quite simple. I think in here. Nope, hang on, sorry. Just want to check. I think on world, yeah, currently I don't have a way of finding all entities or all players or anything like that. So that's yeah, stuff still to come. But it has the basic, setup for launching spawning a ton of players. The reason this is a big deal is because the previous engine couldn't even do this. So the previous engine did not have this idea that I could actually spawn even 1,000 things. I would have had to have written a very specific code for every single instance and then just drawn every single one of them. Yeah, it was just a little bit tricky. But now I can work like a normal game. And then in player, you can see here, basically we want to be a triangle, right? So it stores the pipeline, stores the triangle. I've also added the concept of a orthographic camera. I keep pronouncing that very poorly. It's very simple. The main thing is this, right? You want the projection transform. And so then I've got the rotation values. You can see here that I can actually store them normally now on entities. And then a random position inside of that space. And then the initializer, this is really nice as well, by the way. Like previously I had like a prepare method, but then it meant that you had to make things optional because you have to instantiate them later. Now the whole game is fairly lazy initialized for the things that matter. And so it doesn't really matter. Like I won't call this initializer until it's time, basically. And it will get called exactly once for like every entity. So then basically what we have, you instantiate a triangle using the device. This is because obviously the triangle needs to set up its buffers and things like that. So if we actually go inside of here, you can have a look and see that the initializer here sets up, reuses this other type called color geometry, which is basically just has all the definition of its vertex layout and its vertex position. And essentially it is this color vertex here, right? It's a position and a color, exactly what you would expect, right? And then, let me go jump back here. So we set up, then we store the vertex buffer so we can reuse it. And the vertices are passed in there. There we go. So the vertex buffer, we have to do this sort of unsafe byte stuff, but this is really just for performance. Remember, this is in Pixel 2D, so it's a 2D library that the game uses. The game does not have to write any of this code. Okay, that's why you could write just triangle, but this has to be done for. It's just how it works. But also, again, what you're getting here is a cross-platform solution because this will automatically work on all platforms. And then there's a convenience to just pass one color as well. And then you call draw on it. So if we come back down here, you see that we store the triangle for the player, right? This is be sort of equivalent to like storing the sprite later on. And then down here, we can just ask the triangle to draw itself, right? So essentially for this pass, we're gonna set the render pipeline, right? For this player. Then we're gonna ask the triangle to draw on that pass. I don't know if on is the right word, but it doesn't matter. And then here we're going to pass a transform. So what we do is we also constructed a orthographic camera, and we've sort of set a half height of 25 so we can zoom out. Then we ask the camera for that projection using this render target, right? This is what gives us the correct perspective of the scene for this particular character. Or player, sorry. Then we translate that by some position. This is why it ends up in different positions across the screen. And then, excuse me. And then, as I said, we rotate it, and the rotation is automatically part of a. Actually, And then the rotation is here in every update method. Excuse me. We rotate, and we do that based on. I've got this nice concept of like an update time. So if you come in here, this gives you like the tick index, the delta seconds, but also gives you this nice elapsed seconds, which is a nice way, if you just add a bit of speed or not, essentially it will automatically just rotate. So it's really convenient. And then I just show on the right here, we also now have the concept of a quad, which is basically two triangles. So, but it's a little bit more efficient because we use an index buffer so that we don't have to draw as many vertices for every quad. You just draw, I think it's 6 indices, 4 vertices, which then makes that just slightly more efficient later on at scale. It does more, basically the same thing, you know, if you're just drawing one thing, but later on that's going to matter a lot more. So if I wanted to switch this out, I wanted to show you like how nice this is now. If I switch this out and just say I want a quad instead, right? That might be it. I can do that. Oh. Sorry, 1 second. Let me. I normally would just read the error, but I just want to see if I can quickly take a look, because no, I actually don't see a problem there. Not an obvious one, anyway. This should actually. Sorry, this is why, one of those reasons why I like using like the shorthand, like dot in it. So here, if I now change the type here, everything is just correct, because the APIs are the same. So I think maybe quad might have a problem. Like I don't know if did I test quad? I actually think I did render a quad before. Oh, you know what it is? And I need to improve the error. I know what it is. It's sort of telling me it can't create the resource. So the problem is these, basically my size, my capacities for the render settings are not high enough, because now we have an extra vertice. Is it one extra vertice? I'm going to guess it is. But anyway, so it's going to be a problem. So I think what actually we can do is just lower like how many players we want to create. Might need to be a lot lower. There we go. And so I don't know if you can see that, but I can zoom in here and I can see that they are rotating very, very slowly. So yeah, anyway, so it does work, I swear. I'm going to make this like 2 and 10, like just to get some speed on some of these. Would be nice to actually, there we go. We can see a few of them moving there now. So hopefully, oh wait, that's going to zoom out. I just realized that I went the wrong way. I wanted to say like 15 or something. 1 is essentially like a normal size. There we go. And so I can actually now make this bigger. And so you can see that they're working. But anyway, all of that to say that just changing that to a triangle now gives you triangles. So it's really, really convenient, I think. I think it's a really nice API at the moment. And I'm pretty excited about it. This is going to be, I think the main takeaway here is that if we look at like this one file, right, it's just a player in a game. Obviously right now there's lots of things missing. There's no tile map or background or anything like that. There's no audio. There's not even keyboard input right now. And we also don't have sprites yet, although we almost do, because most of the API for like working with textures is already there. But what I don't have is like asset loading and things like that. So I need to add a few other pieces before I can actually show that. And I'll probably do that later today. But basically right now what we do have is the ability, or I guess what I'm trying to say is, I think right now drawing, even at a low level, like if you're trying to draw just raw triangles, rectangles, things like that, is really, really clean. You have access to all of these APIs. So if you go into like Triangle and you have a look at like how it's built up, you can actually grab this code and do it directly, create some other new type, new shape, whatever. And the entire, I actually didn't show that, did I? But so Pixel 2D is going to be my library for giving you 2D representations of shapes and types and stuff, and textures and stuff like that. And then Pixel 3D will give you more specific types around 3D. I'm not going to expand on this until I need to, but I think I mentioned earlier that I have ideas around this already. The most interesting things to do here would be, like if you have a quad, the next thing there would be that you want a cube, right? And you know, things like spheres and those types of things. So basically you want to be able to, I want to be able to, sorry, add those into like Pixel 3D over time. And also cameras. You want a lot more camera types beyond orthographic in 3D as well. So I'm going to be adding those. And then both of those actually depend on one common framework called Pixel Graphics, which at the moment really just has 3 types in it, right? So it has like this color type. Sorry, the color type is actually in like the platform layer, but it actually has a bunch of, you know, default colors that I've created just to like have a starting point. And then there's a nice helper on frame to clear. So that's why you can just do pass.clear. Normally you'd have to do this, right? But again, we can create a convenience. And then the angle type, which I think it looked like I wasn't even using it, so I need to do that. But this basically is like, I stole the idea from SwiftUI. I've always loved that particular API. It allows you to work with both radians and degrees really easily, and convert between them really easily. So I really love that. So anyway, Pixel Graphics, that'll provide like basic ideas around drawing and geometry. And then 2D and 3D will provide very specific implementations, you know, depending on what you need, and you'll just import the one that you want to use. And then above that is the Pixel engine itself. So the library or the engine or whatever, let me go over that very quickly. It has the concept of a game. This is the thing that you conform to, and this is the thing that will automatically launch the window and things like that. A game context wraps up this idea of like your entity storage and the world, and you know, you register those things, and it's highly performant as well. And it also proxies, you can see here, for like for every world, it's going to proxy through like the fixed update, the update, and the render calls. This is terrible. I did this, but I thought I removed that. Unless I have it in 2 places. I might have done it in world. Sorry, just want to check this now. Oh yeah, I did. So here I did it. I didn't realize that I'd mirrored that actually. I might have copy pasted. Okay, something to come back to. And then there's the performance metrics type, which is just to wrap up metrics. So here like draw counts and stuff like that. Not all of that's printed out yet. And then also that I have like sort of a very basic hitch detection threshold so that I can log at least, you know, if hitches occur in situations where I'm not expecting it. Later, these will become like little HUD UI or whatever in-game, which will be easier to keep track of instead of having to rely on like Xcode console or whatever. Also, that means that on every platform you can render debug information in-game, which I think is pretty cool. And then this is the shader plugin that I talked about. Actually, I think this is, sorry, that's empty. This one might be I was originally trying to put it on Pixel, and I think that didn't really work out. So let me just check if that's actually mentioned in here. If it's not, I mention it, but it doesn't look like I'm, oh wait, that's Pixel Graphics. Yeah, so it's not this one. Okay, so that can go. So there's that. And then the other 2 libraries I just want to quickly touch on, and then I unfortunately have to go because I have another appointment. But as I said, Pixel Platform provides platform abstraction. One of the things that I realized though is that a lot of math, like trigonometry or trigonometric functions, are not available directly in Swift. So what I did was I created a very simple, just the things that I really need as I go. So I've essentially created a simple Pixel math library in C. And then I've created a wrapper. So it's just a shim basically. And I just have very simple types that call through to those C functions. So yeah, really nice and simple. But this way I can, the reason I decided to do it this way is because later this package, maybe I decide to like bring in a C library that's like much faster, SIMD accelerated, you know, intrinsics and stuff like that. Or maybe I decide to write some of them. Now I have a place to do it and all the project structures there. This could be, if this works out and it becomes really useful, it'll be a separate thing I can open source. And then the second thing, which I also would probably like to open source eventually, but it needs a lot more testing, is this one here, Pixel concurrency. So Swift modern concurrency is amazing, but unfortunately, it's just not fast enough, right, for like game engine development or game development. It's not fast enough for audio either. And you really need to work with like lower primitives. So what I decided to do was I created thread and I think mutex. Is that in here? Or did I only do the threading? Some basic, it's not, I mean, I've called things like, yeah, mutex locks. So it's pthread mutex locks. I don't know C very well, if I'm being honest. So I did really lean heavily on like other people's, like looking up online, a little bit on YouTube, and then also AI to help me write the code. At the moment, I think that I managed to get it pretty fast though, so I'm pretty happy. But yeah, maybe it's not great. I don't know. I've not tested the Win32 version yet, but that is another thing that's in there as well. There's actually one, interestingly, I don't think I needed to do a, I'm not seeing it there, and I know I'm using it. So I think that I don't have a web GPU must be showing up as like the platform. I'm gonna assume because I'm not seeing a specific there for WASM. Oh, there it is. There it is. Sorry, I apologize. It does. So yeah. So there we go. So that's, yeah. So basically, for all platforms that I want to support, they're all in there. And so basically, it gives me a really simple, concurrency library there. But what I built on top of it was based on Ryan Fleury did this amazing blog post, or more of an essay a while ago, talking about being multi-core by default. Now I decided not to do exactly that. My engine itself is not multi-core by default. I did that because I started that way, and then I found a lot of things that I don't understand well enough that I felt confident to take that path. And so what I decided to do instead, and I'm pretty happy with this as a solution. So whenever if I come like to my update function here, for example, you'll notice that we pass you like this entity's ID, right? We pass you the world, which, as I said, right now you can't do much with, but you can despawn this entity. But the idea here is that obviously later on you'll be able to look up entities and things like that later. Obviously you get the time, which is great for delta, ticks, time elapsed. And then you get lanes. And lanes let you do some really cool things. So if I go to lanes, you can do this. First of all, you can run this across some data set, and it just needs to conform to lane partitioned. Basically what that means is that it's a special protocol. It's similar to a collection, except it allows me to intentionally and explicitly work over contiguous data that is range based. And so what happens is that you provide some kind of, I'm just going to fake this, it's not going to work, but some kind of data there. And then what you get back here is a lane, I think. I can't even fake it like easily, but essentially, let's go to this. That's the storage. Where's the body is called there? Escaping body, context lane. There we go. Okay, no, I give you back the range. So essentially what happens is here you're going to get back like data. And so from your perspective, it looks like just whatever data, like it doesn't matter that it's the whole range or not, right? And what happens though is that these lanes will execute concurrently. So this closure will get called for, if you have 10,000 items, it's going to get called in chunks.